Hello everyone, my name is Isel Grau. I'm a postdoctoral researcher at the Artificial Intelligence Lab of the Vrije University Brussels in Belgium. And today I'm going to present my work that was already presented at the IEEE International Conference on Fuzzy Systems in the special session of Advanced Unexplainable AI. And the title of this work is An Interpretable Semi-supervised Classifier using raw sets for amendments of labeling. The motivation of this work was a classification problem where we had a lot of unlabeled instances and some labeled instances that were also very imbalanced. So in this classification problem, this is a perfect scenario for using semi-supervised classification techniques, but we also had to take into account that this was a bioinformatics problem where we not only needed to obtain a prediction, but we also wanted to know why we are obtaining that prediction. So we add to our solution interpretable machine learning, and we came up with an interpretable semi-supervised classifier. So in this presentation, I'm going to cover briefly the interpretability in machine learning, the semi-supervised classification background, and I'm going to present the self-labeling gray box and its raw set theory-based amending. And also, finally, I'm going to present the experiments and the results we obtained together with the conclusions. So in interpretability, we have on one side intrinsically interpretable models that rely on their level of transparency to provide an explanation on why they obtain a certain prediction. And on the other side, we have some agnostic post-hoc interpretation methods that try to obtain an explanation on the prediction of an instance after that instance was predicted with a black box model. Somewhere in the middle, we have global surrogates or gray box models that try to mimic the prediction of a black box with an interpretable white box model. And this kind of wrapper model has a very similar structure to a family of semi-supervised classification techniques. So in semi-supervised classification, we have a few labeled data and normally a lot of unlabeled data. And the idea here is to leverage the unlabeled data that we have on top of the labeled data that we would normally use in classification. So the self-labeling techniques are a family of algorithms that assume that the predictions on the learn-based classifier are correct. And for this, they learn a base classifier. So this is also a wrapper structure using the available label data that they have. And then this learn-based classifier is used to predict a label for the unlabeled data. The most confident labeled data is added to enlarged training set, and then this process is repeated. This self-labeling process is very simple, and simple is good for overall transparency, and is easy to implement and applies to almost all existing classifiers, but it has the disadvantage that the mistakes that are made in the self-labeling process can reinforce themselves if no addition is used on the enlarged dataset. So we propose in previous works a self-labeling gray box, which is an interpretable semi-supervised classifier that uses the idea of both gray box models and self-labeling together. So the label instances in this model are used for training a black box classifier, which is the base classifiers of the self-labeling. And then this base classifier is used to predict the labels of the unlabeled instances. So far, that's similar to the normal self-labeling process. But instead of feeding this enlarged label dataset to the black box classifier again, we then feed it to the white box classifier that will try to mimic the predictions of the black box, giving as a gray box character to the entire solution. So that's why we call it self-labeling gray box. The problem here is that the performance of this model heavily relies on the capability of the black box to predict correctly the labels of the unlabeled instances. So we introduce an amending procedure which tries to weight or determine the confidence of the predictions in the large labeled dataset before giving this dataset to the learning process of the white box classifier. So the white box is guided to the most confident instances in the training. For this, we use Ross set theory, which is a mathematical formalism for approximating sets. And the sets here will be the sets that groups data points that share the same label. So what we try to do is to approximate the sets that share the same label and to know how much is included one instance and the similar instances on each of these sets. So for that, we use the inclusion degree on each of the Ross set theory regions, and we compute a weight based on this inclusion degree that takes into account the positive evidence about the certainty of the classification, but also the negative and the hesitant evidence. And this process is repeated for every instance in the large dataset. So we performed some experiments with 55 challenging datasets for semi-supervised classification with the structure classification problems. We ranged the labeling radius from 10% to 40% of the data. And as black box models, we use random forest, and as white box model, we use decision lists, explicitly a part decision list for its implementation. So we run several experiments, and main results were that the accuracy of the self-labeling gray box does not improve hugely after using a Ross sets amending, but the number of rules that are obtained are much less. Are less. So we obtain the same accuracy with much consistent set of rules for all the radius that we tested. Also, we compare our self-labeling gray box with other state-of-the-art self-labeling classifiers, and we outperform these classifiers, yet being far simpler in structure than the other methods. So in general, we introduced a Ross set theory-based amending procedure for weighting the instances for coming from the self-labeling process. And we use the number of rules for evaluating the simplicity of the final model. The Ross set-based amending produces more consistent set of rules without affecting the prediction rates by giving more importance to the confident instances, and the self-labeling gray box can outperform state-of-the-art approaches, yet being far simpler in structure than these techniques. Thank you very much, and I'm open to questions.